The next programming language we are going to consider about is the Ada. Ada is a structured, statically typed, imperative and object-oriented high-level computer programming language extended from Pascal and other languages. Ada is strongly typed and compilers are validated for reliability in mission-critical applications such as avionics software. Ada is an international standard. The current version is defined by joint ISO ANSI standard ISO 8652 into 1995 combined with major amendment ISO IEC. Ada also supports a large number of compile time checks to help avoid bugs that would not be detectable until runtime in some other languages or would require explicit checks to be added to the source code. Ada is designed to detect small problems in very large massive software systems. For example, Ada detects each misspelled variable and Ada pinpoints unclosed if statements which required end if rather than mismatching with any end token. Also, Ada can spot procedure calls with incorrect parameters, which is a common problem in large complex software where most of the statements are procedure calls. Ada's dynamic memory management is high level and type explicit, requiring explicit instantiation of the unchecked deallocation package to explicitly pre-allocate memory. The specification does not require any particular implementation, though the semantics of the language allow automatic garbage collection of inaccessible objects. Most implementations do not support it. Ada does support a limited form of region-based storage management. Invalid access can always be detected at runtime and sometimes at compile time. Ada input-outputs. The standard Ada libraries provide several input-output facilities, each one adapted to specific needs. Namely, the language defines the following dedicated packages: text I/O, sequential I/O, direct I/O, stream I/O. The programmers must choose the adequate package depending on the application needs. For example, the following properties of the data handled by the application should be considered. Simple heuristic for choosing an I/O package. So the most important lesson to learn is choosing the right one. This chapter will describe more in detail these standard packages, explaining how to use them effectively. Besides these Ada-defined packages for general I/O operations, each Ada compiler usually has other implementation-defined input-output facilities, and there are also other external libraries for specialized I/O needs like XML processing or interfacing with databases. Text I/O. Text I/O is probably the most used input-output package. All data inside the file are represented by human-readable text. Text I/O provides support for line and page layout, but the standard is free-form text. It also contains several generic packages for converting numeric and enumeration types of character strings, or for handling bounded and unbounded strings, allow the programmer to read and write different data types in the same file easily. Finally, the same family of Ada text I/O packages for the type wide character and wide character. It is worth noting that the family of text I/O packages provide some automatic text processing. For example, the getLine ignores white spaces at the beginning of a line, or adding a new line character when closing the line. This is thus adequate for application handling simple textual data, but users requiring direct management of text must consider the other packages like sequential I/Os. Direct I/Os is used for random access files which contains only element of one specific type. With direct I/O you can position the file pointer to any element of that type. However, you can freely choose the element type. The element type needs to be definite subtype. Sequential I/Os. Direct I/O is used for random access files which contain only element of one specific type. With sequential I/O, it is the other way around. You can choose between definite and indefinite element types, but you have to read and write the elements one after the other. System I/Os. is the most powerful input-output package with Ada provides. Stream.io allows you to mix objects from different elements type in one sequential file. In order to read-write from to a stream, each type provides a read and write attributes as well as an input and output attribute. These attributes are automatically generated for each type you declare. The read and write attributes treat the elements as raw data. They are suitable for low-level input-output as well as interfacing with other programming languages. The input and output attribute an additional control information to the file, like for example the first and last attribute from an array. In object-oriented programming, you can also use the class input and class output attribute. They will store and recover the actual object type as well. Stream input-output is also the most flexible input-output package. All I/O attributes can be replaced with user-defined functions or procedures using representation clauses, and you can provide your own stream I/O types using flexible object-oriented techniques. Areas of application: government, departments or defense, banking systems, commercial activation, communication systems, computer-aided systems, and manufacturing. Parallel concurrent processing. Ada supports parallel and concurrent execution of tasks.
What we have here is a Arduino hooked up to a fan, driving this fan with pulse width modulation, which is very easy to set up in the Arduino environment. The LED is going to reflect our duty cycle. So the fan is initially slowed down into a stop, and I'm going to start it up here by sending something to the serial port. And by setting the right command, I can lower the duty cycle so that the fan slows down. You can see that by the LED dimming. The fan ultimately will go low, and I can bring it back high.
The next programming language we are concerned about is the Prolog language. The Prolog is a logic programming language. It is a general-purpose language often associated with artificial intelligence and computational linguistics. It has a purely logical subset called pure Prolog, as well as a number of extra-logical features. The program logic is expressed in terms of relations, and execution is triggered by running queries over these relations. Relations and queries are constructed using Prolog single data type. The term relations are defined by clauses. Given a query, the Prolog engine attempts to find a resolution, refutation of the negated query. If the negated query can be refuted, in example an instantiation for all three variables is found that makes the union of clauses and the singleton set consisting of the negated query false, it follows the original query with found instantiation applied is a logical consequence of the program. This makes Prolog particularly useful for database, symbolic mathematics and language parsing applications, because Prolog allows impure predicates. Checking the truth value of certain special predicates may have some deliberate side effects, such as printing value to the screen. This permits the programmer to use some amount of conventional imperative programming when the logical paradigm is inconvenient.